So this is our incremental analysis on foreclosure rates in Los Angeles from the years 2014 to 2019. So the goals of this analysis was primarily driven by the current conversations on wealth inequality and the housing crisis seen in America today. Our goal through this analysis is to recognize what communities in Los Angeles have historically faced foreclosures and what variables could help explain this narrative. We selected the years 2014 to 2019 for many reasons. We did not consider years 2020 onwards because of the coronavirus pandemic. We felt as though those values of foreclosure rates would have been influenced by the ongoing pandemic and wouldn't be representative of what was currently going on in Los Angeles during that time. So for our variables of interest, we decided to look at crime rates in Los Angeles during this time. So we just want to see if these two variables are correlated, if possible. As we'll delve deeper into our data exploration, you'll see why we selected crime rates as one of our variables of interest. As you can see here, try that over. As you can see here, we are looking at this area of focus for our study. We detected 121 unique zip codes during this time. We purposely avoided using regions in the South Bay for this analysis, primarily because there was just no data for this region. They are sectored in their own counties. So this is just data documented by the city of Los Angeles only. And so this is our data exploration and data processing steps. For our first data set, we are looking at foreclosed properties in Los Angeles from the years 2014 to 2019. And this data set was sourced from the Los Angeles Data Catalog, and the data was recorded by the Los Angeles Housing Department. All data accessed from this site is open to use by the public and can be downloaded in the form of a CSV file. So on the right here, this is a small snippet of what we are currently working with in terms of our data set. And we see that there's not very many null values. So to deal with null values in this study, we just decided to drop them or add a 0, depending on, for this analysis, for the foreclosed properties, we just drop the value in its entirety. So as you can see, there's a lot of values listed in this data set. For the purpose of this study, we'll only be using variables such as location, i.e. zip code, to run our analysis. So to break this down even further, we decided to check and see how many foreclosures the city of Los Angeles has per year. As you can see, the highest, hold on. So from the first data set, we decided to break down exactly how many foreclosures the city of Los Angeles have per year. And from this graph and from the numerical values below, we see that 2015 had its highest peak of foreclosure rates and really decreased in 2017. We see it slowly starting to trend up again to up to 2019. Additionally, from the first data set, we decided to see what foreclosure rates what kind of properties were most impacted by foreclosure rates. And we see that single family foreclosure rates were the most impacted, followed by multifamily, vacant residential, and then non-residential. Furthermore, we see that we decided to see if what communities in Los Angeles have consistently faced foreclosure rates during this time. And we broken down by the zip codes on the right-hand side here. We see that from the years 2014 to 2019, these are the communities that have consistently had foreclosure rates in the city of Los Angeles. For our next data set, we are looking at crime rates in Los Angeles from the years 2010 to 2019. This data set was sourced from, again, the Los Angeles Data Catalog and was documented by the Los Angeles Police Department. And on the right-hand side, you could see here that the variables include, but are not limited to, type of weapon used, date occurrence of the crime, where the crime took place, etc. For the goals of this analysis, we'll only look at details that highlight the location of the crime and the date it occurred. Considering how large this data set is, this is a partially cleaned version on the right-hand side at over 2 million columns, but 2 million rows. But after dropping years 2010 to 2013, it reduced the size of the data set significantly. But we do see that for the variables of interest, there are very few null values in this data set. So to accommodate for how large this data set is, we randomly selected about 2,000 rows per year to run our analysis. But for all of our data pre-processing breakdown, we are using the entire data set size. Here, we are looking at how many crimes were committed in Los Angeles from the years 2014 to 2019, again, calculated prior to sampling. We see that the highest year that had the highest crime rate was 2017. And, it kind of leveled off a little bit in 2018 and 2019, but we are seeing its highest peak in 2017. Additionally, we were trying to see how many crimes were committed based on the premise type, again, calculated prior to sampling. And we see here that the second highest location where crimes occurred were in single-family homes. So considering this, we wanted to see if crime rates in Los Angeles could help explain the foreclosure rates in Los Angeles.
Hey, this is Rudrax, master student from ECE department with a specialization of machine learning and data science. And currently we are doing a project for DSCI551, that is data management. And our project is incremental analysis for foreclosure rates and properties for LA, Los Angeles. So what we did was taken 2 data sets and we implemented one EDFS based on MySQL. And what we are doing is taking correlations between those 2 data sets, how crime rate is affecting on the foreclosing rates of properties in LA. We are finding that out. So for that, we have already done the data processing part, and now we are doing the MySQL EDFS integration. So we are using SQL Alchemy that is used for connecting our localhost SQL database to this database, to Python database. We are using PyMySQL, Pandas, NumPy, Regex, and all these things. So let's start the data set. So right now we have already imported the things. We are connecting, these are our project credentials, and we are connecting our configurations with our local database with this one. We are using CSV import, so we are importing the files to this one. Let's see if it connects. And yeah, so it's connecting with SQL. That means that it's already connected right now. So we have made some functions like file ID and directory, which will help us see that we have already got the file system down to the notch. So what we'll be making is a file directory which has parent ID and child ID, and then it will go to directory ID, which will shows the directory ID values and the directories which we have listed from make directory and other functions which we are going to do right now. So let's see the availability part. So this function shows the availability, like it just checks if there's a directory already available or not. What we are doing in file ID create and directory ID create. So we are just like giving them IDs and starting them with some value. So it goes from 0 or it goes from 1, and then it just like increments the rest of the file. And from now we are just doing HDFS functions. So for this, we are also using SQL Alchemy to connect the make direct function. So we are doing the make dir function, but we are connecting with SQL by this connection. So let's select file ID from file, order by file ID. So we are just ordering the files. So now we are running this thing, and let's see if we can make this to directory. So As you can see, I already have user directory and Rudrax directory already there. If I want to change this and to 24, it will say making the directory. That means like the directory has been made. If you want to check this, we can check the SQL workbench. So let me enter my password real quick. And yeah, so when we want to check the files, we can just run the files code. And now you can see the day24 directory has been added to this one. If you want to check the directory, if the directory ID has been changed, we'll check the directory file and let's see if that runs. So now we can see the child ID is now 10 because we have added another in the user thing. So that's how we see that if this make directory works. ls function, that is a list all function. So it will just list all the directories which we have. It shows Rudrax, the way they, whatever we have right now. Cat function works to edit dataset. So this works like when we are uploading a text file, it will just go there and edit the text file when we want. Remove function is like remove directory. So we have made this. As you can see, when we have like, I already have Dave. So if I want to use the Dave file or I want to remove the Dave file, what it will do is, let's see, and it will show us removed. And when I want to just see if a random file is there or not, it will say me no, you're not able to find. So it just goes on to the whole list and just finds that if this user / Dave is available, and it will remove it and kind of like that. So put file. So this function is important because we are what we are doing is we are uploading our data set and creating the partitions in the data sets and using this one. So it just uses read CSV and it's import the CSV file into the function. And then it uses all the functions like make directory, read SQL, all the functions which we have already made, and it just gives the part to that. It also creates a partition location folder. So it will create partitions in it, and the partitions will have that location. That ID will be also stored in a partition locations folder or partition locations table. So let's see that. So it's already run. Crime.csv is already existing path because I already made it. That's why it won't be available. But let's see if the SQL workbench has this. So we'll just reload the project right now. And let's see if we can upload another data set or crime.csv, and we are just putting it into Rudrax/Dave. Okay. Existing path entered, parts number, reference number, got it. Let's see in the reference again. So you can see this one. So these are the parts right now. So like I made two different things. So eight are like for crime.csv, or kind of eight will be crime.csv and the 4 will be, or 4 or 5 will be, because I made different data sets. So it will be just storing them here. Now we are doing the make direct function. This is just like all the HDFS functions combined. So we know that we have to use make directory, ls, cat, rm, all those functions. So we just made a whole function together. And what we are doing is just running them. So we are just seeing that if the ls function is running right now, so it shows that ls function is here. Then let's see if the crime.csv function works. So yeah, like we are just putting crime.csv into this, partition data to your required parts. It's also partitioned our data set. And now it's storing the partition values in this one. So let's see if it's here again. There's a time to partition. So yeah, then right now we can see that partition location is a folder created. And this is here. So what we can do is just check if the partition location has our partition files. And yeah, and let's run this one. So yeah, you can see the file ID and partition IDs are here. It will show you each and every files which they have created and the partitions with it. We can also do the same thing for foreclose, and it will partition this third data set as well. So making the directory, and yep, it will take some time, but yeah, it will load. And now this one would have the foreclose data set as well. Let's just run this again. Yeah, so you can see the 11 is a code for this one, and we are giving the partition for foreclosed CSV as 5. So 5 is a like negative term. So if we're not giving the number of partitions, it will just automatically take five partitions and do it. We're doing the get parts file. So it just shows us the get parts here. Let's see again. We are reading the parts here. So it's reading the first part, the partition here. And okay, so this one is not showing because we stored it in a different path. And yeah, so here it is. The partitions are here. For 11 is the partition created, and 1, 2, 3, 4, 5 are the partitions. And now we have the read parts thing. So it just reads in individual parts. So we have to use this for the next part, that is the search analytics part. So yeah, for search analytics, we use different queries for individual data sets and also those two data sets combined. We also use linear regression, which will be talked about later. So now analytics.zip, this is a normal query which just gives the value according to the zip file. So we are just running that. So this query will run with like SQL queries like select star from this file ID and partition. So we are doing a map reduce function right now. So map reduce will do is it will create 5 map, like it will just take one map and it will link with all the partitions together. So it will just take first file and it will partition, it will give up values from partition 1, partition 2, partition 1, and it will just count the values as well for our analytics part, and we'll get the outputs as for our search part as well. So let's see. And the reducer output is 0 for now. Let's see again. Oh, sorry. We have to change the file name. Yeah, you can see that the 9007 or 9007, that is our USC's pin code, which how many files are there, like how many properties are there, kind of it will show us. All the analytics will be here. So it will just show us the value of map1, all the individual partition files, and also the total of it. So that's the reduce function. So we are doing the same thing for all of them. So it's a different zip. This is like greater than this one. So we have to run this one. So it gives this values for some property types. If we want to check the property types from foreclosed, what we are doing is, and so what we're doing is like we are checking if there's a single family living in the property, and they're just showing all the data sets from all the partitions from single family. Let's do in the crime data set. So what the crime data set shows us is how brutality and how crime is there in particular location and particular areas. So we are just checking if the weapon code is 505, that is not here in the data set. We are just checking that a negative possibility, that will give us 0, 0 outputs. And we are checking if the crime code is 740, that is crime code given by police here. So that's used by here. So they are just like listing it in the data set. And that's the way we get like this partition, that these are the outputs where the crime code is 740. And yeah, that's all. So you can see the 740 is here. Thank you. Have a good day.
And so we decided to run a correlational analysis for this study. After comparing the two variables together, foreclosure rates and crime rates, unfortunately, there were no correlation values between the two. Although these are not the results that we expected, we can officially rule out that these two variables may not be the reason why we are seeing foreclosure rates in Los Angeles, and should help the city of Los Angeles, explore other reasons or other features that will explain otherwise. And yeah, thank you so much.